So our topic is here IP addressing. So if IP, it means IP stands for Internet Protocol Addressing. And if we don't have IP addressing concept, so we cannot assign the IP addresses to end host or end devices or servers or any network devices. So if you want to communicate at one location to other location, if you want to communicate at one geographical location to other geographical location, we require a IP addresses. So step by step we'll discuss. IP address is a logical address and it will work in layer 3. In OSI model, we have layer 3, that is network layer. IP addresses will work in network layer. IP addressing is a logical address. It is a network layer address. It's work on layer 3 and IP address is given to every device in network. It is used to identify the device within the network. So within the network, or if you want to communicate any geographical location, so IP address is mandatory. So every device we should have to give the IP address. Without IP address, we cannot able to reach at one location to other locations. So that is the reason we need a IP addressing. And who will give the IP addresses? Who will provide the IP addresses? INA, Internet Assigned Number Authority. The Internet Number Assigned Authority, they will provide it, it's an organization. So it will be, they will provide to us. It's ocean level, like Epic, whichever the ocean level we have INA services, they will provide to us. Anyone have any doubts? Guys? No. Okay, feel free to ask if you have any questions, any doubts, feel free to ask in between. And see, guys, earlier we have IPv4 IP address, and here we have two types of versions. So limitations of IPv4, we have another version also, that is IP version 4. So here we have two types of IP versions, IP version 4 and IP version 6. The main difference is IP version 4. Here we have the limited of IP addresses, and IP version 6. Here we have the billions of IP addresses. Here we have the lakhs of IP addresses only in IPv4, but it means here we have 2 to the power of 32. 2 power 32, whichever the value will originated, that is the IPv4, and IPv6 is 2 power 128, because it's 128, it means it's a bit size, and 32, it means bit size. I'll explain those things. But time being, IPv4 having the 32 bits only, and IPv6 having the 128 bits. These are the two types of IP addressing we have. Two types of IP addressing. This is all about the introduction of IP addressing. If you have any questions, just ask me. Guys, understanding? whichever we are discussing.
Yes, sir.
Good. So now move to the IPv4. Here in IPv4, it's 4 octet and 8 bit per octet, and it's 32 bits of decimal number, 32 bits of binary number. Sorry, that's the binary number. See how we'll differentiate it. So it's 4 octet means actual will converted like 1.1, sorry, 1 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 and 1 2 3 4 5 6 7 8. So here the value is 8 and plus 8 plus 8 plus 8, sorry, 8. The value it will be is equals to 32. So here 1 2 3 4 5 8 plus 8 plus 8 plus 8. Here this is the one octet, first octet. This one is the first octet, and this one is the second one, and this one is the third one, and this one is the fourth one. We have 4 octet. In each octet we have in each octet we have 8 bits. Yes. In each first octet we have 8 bits, and second octet we have 8 bits, and third octet we have 8 bits, and fourth octet we have 8 bits. Totally we have 32 bits of information. It's a binary format. If you want to see this same format in decimal format, this is a decimal format 192.168.1.1. This is a decimal format. How will convert? I'll show you that. How we'll convert, and till now anyone have any queries? How we got the 32 bits? IPv4 having 4 octets, first octet, second octet, third octet, and fourth octet, and each octet having the 8 bits. Total bits are 32 bits. It's a binary format. If you want to check this decimal format, it will be likewise. And now move to the how we'll convert binary to decimal. Binary to decimal format. So simply, I'll take here only one octet, that is one dot. This fourth octet I am taking now. One. Here we have 8 bits. One, 4, 5, 6, 7, 8. So the values will 2 to the power of 0. It will be start. The 2 power 0 value is 2 power 0 value is 1 actually. And 2 power 1 value is 2. Now move to the 2 power 2 value is 4. 2 power 4 value is 8, 16, and 32, 64, 1, 2, 3, 7, 8. Wait, guys, I'm setting 128. No issue. Check here. Now you understand the values, how it will got it. Now move to the, for example, I'm taking here the value is, if we have one value, it will be answer is like 255, because just calculate 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. The value it will be originated like 255. If we are have value like if 192.168.1.1, then the binary value will be originated like 129. Oh, binary value is 1 and 1 and 128 plus 64. The value it will be same. Just 128 plus 64 and 192, and just give the all the bits are 0 0 0 0, 8 bits, and for this is the binary of this value. And now from 168, value is like 128 plus 32. How much? It will be 2 160 plus 8, 168. So 1 and 0, again 1 and 32, and 0 we know it, known it's 16, and 1. Apart from that, 0 0 0, whichever the closing bits, those are the host. I'll explain that, but how we got the binary value, I'm explaining those things. 0 0 0 0 5 6 0 7 zeros. One value is binary value is this one 1, and for this 1. This is a binary format, and this is a decimal format. I hope everyone got it. Now move to the. I'll explain like a role based and 8 octets we discussed and here 32 and each octet we have likewise same thing. This is a rule one. Let's go through this. See what it is defining. It is 32 bits address and divided into 4 octets and each octet having 8 bits and bit represented as 0 will and 1. This is a binary and IP address is in binary format. Likewise, it's 32 bits and 32 bits are divided into 4 octets. Likewise, 4 octets and IP addressing in decimal format. Likewise, this is a rule 1. We have different rules here and second rule will move. Each and every octet minimum value can be 0 and maximum value can be 255. What does it mean? In rule 2, each and every octet minimum value is 0. Yes, the minimum value is 0 and maximum value is 255. How it will become? It will be, say, see here, 1. If you know this concept, then only you can understand. So just calculate it. Here we'll get the 255 the value. It's a maximum value. This is a maximum value of 255. We don't have after then 256. If you can calculate it, if 2 power 8 value is 256, 2 power 8 value is 256 only, but we won't take the 256 value. No, this is not a proper IP address. We cannot assign likewise 256 IP address. Up to 255 only. We can assign the IP addresses or we can take the broadcast, whichever the network ID. Up to 255 only. We don't have 256 IP address. If you calculate 2 to the power of 8 value, it will be come 256. We won't take likewise. The maximum value is 255 only in IP addressing. This is a rule 2. And in rule 3, IPv4 is divided into 5 different classes. We divided IP addresses in 5 different classes. Class A, Class B, Class C, Class D, and Class E. Up to 5 classes we have. We divide segregated like IPv4 divided into 5 different classes. In that Class A, Class B, Class C. So I'll have one image. So here you can check class A IP range is from starting from class A IP range starting from 0.0.02 and 127.2. 255.255.255. Before that, I'll explain something. So IP address range is basically starting from 0.0.0.02. Maximum value is 255.255.255.255. In between only the IPv4 range is there. IPv4 range is 0.0.02, 255.255.255.255. The maximum range is up to here only. After then, we don't have any range. No, this is a not proper range. We don't have up to this much only in IPv4, the maximum range. So in class A, the range will be start from 0.0.02 and 127.255.255.255. The range A, class A. The range class B is 128.0.0.2, 191.255.255.255. And class C range will start from 192.0.0.2 and 223.255.255.255. And class D range start from 224.0.0.02 to 39.255.255.255. And class E range is starting from 240 to 245.255.255 to 255. And here it's a very large network. Is class A is very large network because we have 16 billion IP addresses. 16 billion and 7,77,000 to 16 IP addresses. And the range, how it will become, I'll show you how the range will came. Just the old range is 2 power, I told you 2 power 32. This is the old range. You can calculate. This is the IP addresses we have in IPv4. Now coming to IPv4, in IPv4 class A range, how we calculate likewise. So here the range is 24 because this is the 4 octets are there. Before that, see, in every octet, we have host bit and network bit. So in class A, if you know these things, then you can easily understand that. Class A, we have like 8 octet, each octet in 8 bits, and 4 octet we have. First octet is network bit, and second octet is network bit, and third octet is network bit, and fourth octet is a host bit. Now coming to class B, here first octet is network bit and second octet is network bit and third octet is host bit and fourth octet also host bit. And now class C will use up to class C only in real time. We don't use like multicast IP addresses. Multicast IP addresses, that is different scenario. We'll use in different scenario. But now class D is research purpose. Those are the wastage only. No, we cannot use because all the devices can understand routers and switches, whichever the servers, all the devices, all the network devices can understand only up to class D. Because we haven't assigned these IP addresses, they'll assume like earlier we can use for the research purpose for future use. Now we don't use this kind of these IP addresses. This is a wastage of only class E is wastage only now. Now coming to here, what is host and what is network? Host,
Class A and C are same, sir. Network host.
sorry,
Class A and C.
sorry,
Network host. Yeah.
sorry. This is only one here. Here three networks. Here two networks, and here only one network. So each octet we have like now move to the binary. Now move to the binary here. 1.8 plus 1, 2, 3, 4, 5, 6, 7, 8 plus 1, 2, 3, 4, 5, 6, 7, 8. Now all the zeros. These host bits always are zeros because this is now we can assign whatever we require. It means so here the value it will be 255 and plus 255 plus 255. The is equals to value is if meeting ended, rejoin please. If meeting ended, rejoin the same meeting. And so here the bit is 8, right? So the value it will be binary. This is the binary. This is the hexadecimal. Now move to the octet values. This is 8 octet, 8 plus 8 plus the value 8. So plus 0. So the value is how much? 8 plus 8 plus 8, 24. Try to understand, guys. Here, this is a plus 0. So what I told you, the 24, the value is 24. This value will come. This many IP addresses we have. Now move to the this one. Now we have like place one place one 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 one. Two host bit only. After then all are the zeros only. 0 0 0. 8 zeros and plus 8 zeros. The value will become like 8 plus x 16 is equals to 16. Understood how it came? The 8 plus 8. This is remaining host bits are 0. We won't take host bits are 0 here. So that is the reason. Now here the value is 16. So their value it will become 2 to the power of 16. 2 power 16. The value will become here. Like now here only one bit is open, that is in class C 1 8 plus 0 0 0 all the zeros equals to 8 only. So here value is 2 to the power of how much? 2 power how much?
8.
8 exactly. The value is 256. So we have the host bits are here 256 because of this 2 to the power of 16 because of 265,000 we have and here 16 billion. So this is the valid and up to class C only will use and it's a medium and it's a large network and it's a very large network. in this, and IP addresses likewise. And now move to the class D. It's a multicast IP address. We don't have the network IP address and network bits. This is the network bits. This many you can assign. You will get the find out. It will be later. But time being, it's only one here. If because of every IP address we are using, we cannot use here subnetting. Like if you can assume, like in OSPF we have the multicast IP addresses 255.255 dot sorry 240 224.0.0.5 and 224.0.0.6. Both are different IP address. Both are the multicast IP addresses, and those multicast IP addresses will send the group of information to group. It will be sent, and here before that, unicast, broadcast, and multicast. So unicast is one to one the communication, and broadcast is one to all. So this is the broadcast IP address. This one is the broadcast IP address. This is a broadcast IP address. It will be select how many groups are there. It will be sent all of the information. Broadcast IP address. This is the network ID. This is a network ID from starting IP because it's a network IP, you can assume. And this one is a broadcast IP. Anyway, we'll discuss those things. Till up to here, anyone having any doubts? And what is network and what is host bit? Actually, the network bit is like specific device we can assign. Whichever our specific devices, we can assign this network bit, sorry, a host bit. If it means you have one end PC, end user, we can assign for this. If you have multiple end users, 100 users if you have, will assign host bit only. If you have router here, will assign for this port, same thing. Network host bit only will assign here. Host bit only will assign. What about the network bit? Whichever the set of IP addresses, in this set of IP addresses, here you can assume like this is 0.0.0. This is a host bit, and apart from this, these all are the network bits. This is a set of devices we can assign. For time being, that much only you can will get later and more brief about it. And if you want to more information about network and host bits, we'll discuss. Till up to here, anyone having any doubts?
No.
No.
Fine. The concept is understanding, right?
Yes, sir.
Good. Fine. So here network address. So as I mentioned, first IP address of the range, whichever the first IP address of the range. For example, if you have 192.168.1.0/24, slash value is nothing. Now time being, forget it. Now, we take a subnet mask. Okay. Subnet mask 255.255.255.0. This is the subnet mask of class A. Class A 255.255.255.0. This is the class A subnet mask. This is the starting range and this is the end range. In between, we have like 256 IP addresses. Those are the valid IP addresses. Those are the valid IP addresses, and whichever the first bit, first IP address, that is the network IP, and it represents the complete network and cannot be assigned to any device. Yes, we cannot assign this network bit to any device. If you are trying to assign this network bit, it won't take. We cannot assign any IP, any devices. The network address is represented with all bits as zeros. See here, the 0 is represented. That is the network bit. Whenever you have seen here 0, that you can assume that is a network bit. For timing, you can understand 0, but here we'll get the different values also. Whenever we are doing the VLSM or FLSM subnetting, okay, in the host, but whenever you are seeing the routing table, it will be see like 0 only. Whenever you are seeing the routing table, those are the advanced topic. But for time being, whenever you see like 0 here, that is network bit. Host portion of the address, broadcast address. No, sorry, host portion. The host portion of the address, whichever the host portion in between, that is that. Those are the IP addresses we can assign. It means from starting range is like here you can take